Okay, there's Tar Baby with the two LEDs, the Loads of Doom LEDs there, and instead of the 9-volt battery, I have Tar Baby hooked up through the jumper lead to this 7100 or 71,000 microfarad electrolytic capacitor. Okay, and and over here I have the L&Co power supply set to 10 volts. All right, and so what I'm going to do is charge this capacitor up to 10 volts using the L&Co power supply. And so here's the L&Co output leads. So one to the positive and one to the negative. This will only take a moment. Watch the meters on the L&Co. Boink. Okay, so we got the very quick current surge as the cap charged, and now we're reading the cap voltage at 10 volts. Right. Okay, so now I'll just disconnect the L&Co from the capacitor. So now this capacitor is charged to 10 volts. There's the circuit. So now all I have to do is turn it on, right? By hooking up the positive lead. Like that. If I can get it to stay on there. I guess you could see that the oscillations began immediately. There's a strong negative component there. This is being shown at 50 millivolts per division right now because I wanted to track it for a while. Oops, there went the trigger. Okay, so you can see that the amplitude of the oscillations is shrinking a little bit, but we'd still have a really strong negative for a while. Shrinking, shrinking, shrinking. And if we finally get to the point where we can no longer trigger the oscilloscope, but it's still oscillating until it goes down to the voltage where the capacitor won't run it anymore. Okay, let's try that again. Let's disconnect the capacitor. Let's charge the capacitor using the L&Co power supply to 10 volts. Let's hook up the circuit again. Oscillations begin immediately. I can get the scope triggering. Strong negative component. Circuit's definitely running on a capacitor. But it looks like the capacitor is not being recharged or prevented from discharging by this negative component here. Trigger back. Let's see if we can follow that now. I'll change the amplitude there. So now we're still going down, down, down. Change to another higher setting. We're triggering on this trace, so that's why I have to keep changing the setting. And then finally the oscillations. Oh, now they're gone. Finally gone. And now I think you can see the current here is slowly decreasing a little bit. It's approaching the baseline. Decreasing, decreasing, decreasing. Okay. So let's do it again. Why not? Well, let's go back to where we were here. Okay. So let's charge the capacitor. That's all it takes. It's just a brief touch to charge the capacitor. Now let's Hook up the circuit. Oscillations begin immediately. And yes, both LEDs are lit. Right? Both LEDs are lit, just as before. Oscillations are there. Still running just on the capacitor. Decreasing amplitude here. So to keep the scope triggering, I'm going to change the amplifier setting. We're now at 20 millivolts per division on this current trace. Changing again. Now we're at 10 millivolts per division. Again, 5 millivolts per division, and that's as far as we can track it. So, Tar Baby definitely runs, making negative power product using a capacitor only as its power supply. And it runs for a fairly long time. And if we had a truly large capacitor here, it would run a really, really, really long time. Thank you for watching.